Welcome to Casualty Connect, our video series featuring industry experts on the use of artificial intelligence in the property and casualty insurance. I'm Frank Giaoui, CEO and co-founder of Optimalex, and our guest today is Gregory Schibler. Greg, you are a professor of business analytics at University of California in San Diego. You have been specializing in data analytics for the last 30 years, mostly in finance and insurance industries. I have a first question for you, which is, how would you define data analytics and business analytics in the property and casualty insurance industry?
You bet. And thanks, Frank. Appreciate your having me here. I guess broadly, in those industries, oftentimes predictive analytics is the sort of thing that we end up talking about. But I think, most broadly, it comes down to the value of information. And the classic understanding of the value of information is what is the difference in action that you're going to take with the information versus taking action without the information? And what is the delta in the outcome value associated with that? So in this case, for example, if we're talking about an underwriting example, if I have very strong analytics that give me a very good idea about what the outcome is going to be in the future, I can make a better action about pricing or choosing to underwrite a particular policy such that my bottom line is going to be better off in the future. And of course, implicit in that understanding of the value of information is the fact that you are taking action upon it, which also implies that you're able to get to that information in a timely enough fashion in order to take that action when you need to. And I think as we go through, we'll probably see some examples of that coming into play.
Thank you, Greg. So now the subject is artificial intelligence. Those technology, those methodology you are describing are not new, but artificial intelligence, which is more recently implemented, has changed drastically the use of data analytics. Can you explain how this has changed recently?
Sure. And I think the broadest piece of it really has been a continuum, and we've been seeing this over the course of 30 years or more, with computational power becoming cheaper and cheaper, and of course, tools becoming functionally easier to use as we go through. But of course, that's even more true today. We have the horsepower to throw much larger data sets at problems and to throw much more complex analytic models at those problems. We also now, with the large language model capabilities that are coming out, we've made it so much easier for analysts to design and execute those experiments through using the large language models, things that may have taken days to code through previously in SPSS or some other statistical package out there can now be done by essentially speaking a short paragraph to a ChatGPT asking for a Python execution of that same component. So really, I think the value or the interesting thing there is the democratization, if you will, of analytic capabilities. More and more people are able to do it. They're able to throw more and more data at the problem. And while that is wonderful on one edge, there tend to be a lot of potential problems that come with that too. If you're over relying on those computational cycles, the automation and the AI, you're going to run into issues with poor data quality, mistaking correlation for causation, overfitting of results, unethical use of the data potentially. But I think far and away, the biggest challenge that we run into with this piece is that not enough business context or business acumen is put into the process at the beginning. It's not really planning for exactly how that action is going to take place. And so I tend to speak with clients about recommending that they always start at the end of the project and work backwards.
Wow. Okay. So let's take that step by step. Essentially, you are saying that AI is making all those analytics much easier. much user-friendly for a non-data scientist. I understand that, but how does that um, increase the danger of misusing the technologies? You were alluding to that before going to the illustrations and the examples.
You bet. Yeah, we'll have some examples where that sort of thing has occurred, but um, what is the right way to approach that? Effectively, if you now have someone that hasn't spent a tremendous amount of time with data and with actually implementing results of these kinds of challenges, they could potentially grab an inaccurate piece of data to start with, or an unethical piece of data to start with, and they could then ask for a very complex model type that would effectively overfit the results without realizing that overfitting was occurring. So there are all sorts of components there, but even more so is wasting cycles, spending time building out models and analytics that you ultimately can't take action upon. So I really think that, taking that time to understand exactly how it's going to be used, when exactly it's going to be used, who's going to use it, do you need specific help in data flows? Those sorts of things are really what will help ensure success with a project as you go forward.
So it increases essentially the responsibility of defining the scope of the project, the use, the objective, essentially your business strategy before going to the technology, which is very accessible. You said before, start by the end. Can you explain what you mean by that?
Sure. And actually, I would maybe clarify slightly that last statement that you made, which is uh, not that it's any more important to really understand the business problem and plan for that from the beginning. That's always been critically important. It's just potentially easier to skip now that we have all of these tools that make things so simple to dive right into the analytics. That said, my notion of starting at the end, I often, when I've worked with clients, I've started with the notion of, imagine you have a crystal ball and that it's going to give you an exact answer of what's going to happen in terms of making a prediction. And we can, equate that to any particular line. If it's a claim adjustment scenario, I know from minute one exactly what the end result is going to be. You then ask yourself, well, what are you going to do as a result of having that information, right? And you're going to work backwards from okay, I've got this answer. Who is going to take action on it? How am I going to get the information or the specific action that I want them to take if you're talking about an end user? How am I going to get that in their hands? When exactly do I need to put that information in their hands? And there are implications associated with that relative to what data are available at the specific time that you need to make that decision. And then there's also the implementation environment. So where are you going to build the paths to get the data that you need? And where are you going to build the paths to get the information to the person or the system that is actually going to take that specific action? And are you going to need help with that? Is that an IT bandwidth constraint that's not going to let that happen? Is there a management buy-off that's going to have to come in? Is there a compliance office that's going to weigh in on whether you're grabbing the appropriate data or not? But by starting at the end like that and working backwards, you ultimately have the ability to think about a cost benefit analysis up front and think about, how much is this really going to be worth to me? And how good does my model have to be in order to be valuable? No, I started the premise with, you have a crystal ball that gives you a perfect answer. No analytics are going to give you a perfect example, so a perfect answer. So instead, by doing effectively thinking through the implementation from the beginning, you can figure out, well, what level of performance do I actually need for this to be a worthwhile project?
Right, right. Understood. So let's switch to some concrete examples, maybe of common mistakes that you have seen with your clients in insurance. Let's focus on casualty insurance, if you don't mind,
Okay.
and let's start maybe with an example where the lack of knowledge of the data and the context was, of course, leading to a serious problem. And how would you solve the issue?
Sure. So I'm going to start with what I would call an absurdly simple example. This was a PNC insurer that we had been working for. They were buying leads from third-party aggregators, and they had their analysts calling those leads, trying to close business. And of course, they didn't close a lot of the business. So the call centers were working. Uh, the vast majority of the calls that they made did not close. So what we've been working with this client for some time, and we had actually developed a really strong model that worked really well. Uh, we were able to append, based on the information that was on the lead form, we were able to append some additional sociodemographic data, and coupled with the information that they provided on the lead form, we were able to build a model that would predict whether they were likely to do business with this carrier or not. And so we could then sort all of the leads that had been purchased, and we let their sales reps make calls to those leads that were most likely to close. And of course, that upped their business significantly. So our model is able to explain about 30% of the total variance that was in the data that existed there. And one day, we had this model running for several years. It was worth tens of millions of dollars to the bottom line for this client. And one day, I got a call from my my contact at the carrier, and I was the analytics lead, and we'd had a really good relationship. So he called to tell me that he just, wanted to thank me for all the work that we had done, and to give me a heads up that he was going to contact the sales team and send a notice of non-renewal on the account, because they had hired a young data scientist, and he had built a model that was significantly better than the one we had deployed. And of course, that seemed reasonable. We were a vendor. We spent a good amount of time on a model, but we weren't, 100% focused on that problem alone. So I understood that someone could beat it. But we talked a little bit, and I asked him out of curiosity, how much better were they really able to do, expecting that if they could kick from 30 to 32 or 33%, that would be a huge increase to their bottom line. And of course, he said he was almost embarrassed to tell me because they'd blown us out of the water. And when I pressed, he said, well, their analyst had actually found like 98.5% of the variance.
Oh my God.
Yeah. And of course, I just, it was all I could do to not laugh. But, we talked a little bit more. And of course, what happened is that they had just given this analyst the combined data set of the information that they had originally given us, along with a bunch of the data that we had appended from sociodemographic components. And in total, there were probably 800 variables on this data set. Our model had 12 to 15 variables in total in the model that was in production. This analyst used one of the machine learning tools and created a model with almost all 800 of the variables in the model. And it turns out that some of the variables that were in the model that shouldn't have been in the model, but were on the data set, was information about the customers, and did they pay their premiums on time and things like that. And of course, with one variable off of one hindsight data element from that file, they easily could have had a model that was better than 98.5%. Yeah. So instead, they'd thrown all this horsepower and all of this computational power, and included all of these unnecessary variables in order to totally get confused by the noise that existed in the data. And the bottom line, of course, is that there's absolutely no way it could possibly work in production. And had they actually canceled the contract with us and put that model in play, they would have lost millions of dollars in terms of new business.
Of course. Is what you are describing, without going too much into the technicalities, is it a typical problem of overfitting?
So yeah, overfitting tends to be a very large problem these days. In fact, there's a component of this that comes from what I sometimes call algorithm shopping.
Yeah.
Again, this is going back to this theme of the large language models making it so easy to, hey, ChatGPT, here's a data set, attempt to build a backprop neural network model, a gradient boost model, a random forest model, et cetera, et cetera, et cetera. And, tell me which one works best. And in those scenarios, without spending the time to really think about what is the business context, what is the business problem, does it make sense that a particular variable would deliver value in this context or not? Effectively, what they're doing is figuring out which of the algorithms does the best job at nitpicking the noise that exists in the data. And so, yeah, that's definitely a problem.
Thank you. There is another issue which you alluded to, is what we have qualified as being over-reliance to some quantitative metrics without a proper understanding of their meaning and their business implications. Maybe you can give us a couple of examples on your experience for this issue.
Sure, happy to. And yeah, this is very much a classic problem, and it's actually been a problem for a long time without spending the time to really think about exactly how is a model to be deployed and how am I specifically going to take action upon that model. What's going to happen. So many of the metrics that analysts used and have used for years, we talk about R-squareds, RMSEs, Kolmogorov, Smirnov, statistics, et cetera. And these are all really good measures of, an overall performance. And in general, a model with a higher RMSE is going to be better than a model with lower RMSE. But an example when that's not the case. And, we've certainly seen plenty of times where a lower performing model from one given statistic actually delivers more value to the client in the end. I can think of one, this was actually a credit card risk model that we had deployed. And in this case, there was sort of an interesting classic adverse selection problem going, because those that most wanted the credit product are those that were least able to apply and be accepted. And so the challenge here is, they were rejecting, based on the population that was coming through the door, they were rejecting about 40% of the applications. Well, there's nothing so there's a specific action point in that scenario. If I were to sort the applications from best to worst and say I'm going to scrape off the bottom 40%. If you look at an RMSE, for example, there's nothing about that 40% line inherent in the RMSE. So instead, you really want to be looking at, well, how well does this model sort the worst 40% to the bottom of the file? And so we actually had a case where when we came in and started working with this client, as I said, they were rejecting 40%. This was based on a model they had in play that was based on some standard metrics. And what we actually were able to do was immediately demonstrate that we could outperform their existing models at that specific point of action. And actually, by continuing with that basic thought process, we got to the point where they were actually able to increase their acceptance rate from that 60% number to about 65%. and at the same time decrease their risk profile. So it's, that second problem, not having the business context or the hypothesis testing that up front prevented them from finding a much more optimal solution.
Understood. So thank you very much for those examples. Now we are close to the end of our video. Would you mind wrapping up how those mistakes, commonly described mistakes, but not really new to AI, how does that change with the new technologies?
Well, I think it really just underscores the need to, think the implementation through ahead as being critically important, because it is now so easy to dive into the analytics, to be able to say, oh, here's a data set, and throw this at one of the LLMs and say, evaluate a whole bunch of different modeling capabilities and come back with what's best, right? Um, and that's so easy to do, and to spend a lot of time chasing, only to find out that, well, you really didn't give the business context up front. You hadn't thought through the business context up front. And ultimately, whatever you've done becomes wasted effort.
Yeah.
So starting at the end and working backwards corrects so much of that. For example, I had talked about the model that the person had used data that existed after a sale to help predict whether a sale was in play. Designing that correct modeling data set is something that comes with understanding the business problem, thinking through, when am I going to take this action, right? So I need to understand what is the data that will be available at that particular moment in time. And so again, thinking that through helps you design the modeling data set that you're going to ultimately pass to those analytics tools that are out there. Knowing that you can get the data through whatever the implementation path is means that you're going to be able to actually take action upon the model when you're finished. And you know what that very specific action is. I'm going to have a rep call this lead versus there's no point in having anyone call this 10% of the leads, because it will actually produce negative profit in terms of the time. The amount of new business is so small that it's a complete waste of time to chase that information. Those are all things that.
Yeah.
Sorry?
I said decreasing marginal return.
Absolutely. Focusing the effort where the margins are great. And again, thinking through the deployments ahead of time allows you to do all of those things that are critical, from designing the correct modeling data set to the point of implementation to what action will be taken by whom and when. Means that when you actually do develop the analytic project and you come out at the end, you have something that you can actually take action on and truly impact the bottom line.
Thank you very much, Greg. You were our guest today. You are a professor of business analytics at University of California in San Diego. And I'm Frank Giaoui, CEO and co-founder of Optimalex. That is our Casualty Connect video series on AI and property and casualty insurance.